to what I promise will be a much shorter video than last time about what we call resistance and how it connects voltage and current. Your homework for tonight is to answer these two questions. The first one is multiple choice, and it says if the resistance of a circuit were tripled, then the current through the circuit would be what? 1/3 as much, 3 times as much, or unchanged. And we're assuming here that the potential difference does not change. And number 2, what is the resistance of this resistor? I want you to use the chart to tell me how strong of a resistor this is. So now, when we test a circuit that has current flowing through it and it's connected to a potential difference, it's found that the current flowing through that wire is proportional to the potential difference between the two ends. And this makes sense, right? If we use a really, really big battery, if we plug a car battery up to a circuit, we are going to get more current through that circuit than if we used a 1.5 volt AA battery. The more voltage we have, the higher the current. Now, Ohm came up with a law that actually related these things in an equation. And Ohm's law states that a steady current flowing through a material, so this has to be direct current, can't be alternating, a steady current flowing through a material of given resistance is directly proportional to the voltage and indirectly proportional to the resistance. Breaking it down, what that means is the more voltage, the higher the current. And the more resistance, the lower the current. And we say that as the equation V equals IR. It's pretty easy. If you walk away from this class only knowing 2 equations, please let them be F equals MA and V equals IR. V, as we know, stands for electric potential, measured in volts. I is the current, which is the flow of charge, or how fast it's flowing, and we measure that in amps. And R is a new thing that I'm going to tell you about. This is the resistance. And it is exactly what it sounds like. It is the resistance to the flow of electricity. If we have something that has really high resistance, the electrons are going to have a really hard time getting through it, and the amount of current flowing is going to be very low. If an object has very low resistance, the electrons are just going to go through it no problem, be on their merry way, and there will be a lot of current. This happens in conductors, and in many conductors, the resistance doesn't depend on how much voltage we have. So it doesn't matter if you plug your resistor into a AA battery or a car battery. It will always have the same amount of resistance because resistance is a property of whatever material you have. So we know that copper is a much better conductor than rubber. And that has to do with the amount of resistance to the flow of electricity through it. Whatever materials do not depend on the amount of voltage present is called something that is ohmic. If it does depend on the amount of voltage, it's called non-ohmic. So this one right here, ohm. This top chart shows a picture of something that is ohmic. It does not matter how much voltage you put in. The slope of this line, or the resistance, is always the same. It does not change. The one down on the bottom is non-ohmic. As you add more voltage, or you have a higher potential, the slope of this line changes, and the resistance changes. So in this one, where we have more voltage, we have a steeper sloped line, and that tells us that as the voltage increases, the resistance resistance increases. Now we measure resistance in ohms. And the ohm has a very special symbol. And this is the capital omega. So if I want to say my resistor has a resistance of 3 ohms, I don't write OHMS after. I write 3 ohms as omega. So this is what your units will look like for resistance. Now we know that resistance is a property of whatever material something's made of. Because of that, we can manufacture resistors that have the exact amount of resistance that we want for a given purpose. So this is a standard resistor. It has 2 wires coming out of the end, and it has a certain amount of material in it, or a certain kind of material, to produce resistance against the current flowing through it. And they're color-coded to tell us how strong they are. When you are reading the resistance on a resistor, this is how you do it. The first band, which is not the metallic one. So there is a metallic band on one side of every resistor. That is never your starting one. So you're not going to start with silver and work your way down. In this case, you're going to start with red and work your way down. So the first band is your first digit. And I have a special chart that we're going to use to try and figure out the resistance of this resistor. The second band is your second digit. So you would go to your chart, find the color red, whatever number corresponds with red, that's your first digit. Go to green, whatever number corresponds with green, that's your second digit. The next one is orange, and that is your multiplier. So that will tell you times 10 raised to some number. If it's times 10 raised to the third, that means you take whatever number this is and multiply by 1,000. If it's times 10 to the 1, you take whatever this number is and multiply by 10. And finally, the metallic band is your tolerance. So let's go ahead and try and see if we can figure out how many ohms of resistance this resistor has by using a special little chart that I have here. So our first digit here is red. So we look at red, it's right here, and the number that corresponds with red is either 2 or times 10 to the 2. Now, because this is the first band, we want to look at the number, not the multiplier. So the very first number in how much resistance this has is 2. Our second band is green. So we go over to our chart again and we look at green. It's right here. And again, we want the number for this, not the multiplier, because this is only our second band. So the second number is 5. Now the third band, orange right there. The third band is orange. So let's see if we can find it. Orange is right under red, right here. And now, because this is our third band, we want to look at the multiplier. And the multiplier for orange is times 10 to the 3. So we take that, and we have 25 times 10 to the 3. Our last band is our tolerance, and that is silver. And the silver and gold, or our tolerance, is way down at the bottom here. Silver is a tolerance of 10%. Sorry, we don't use it as a multiplier. We're using it as a tolerance. That's 10%. Plus or minus 10%. So the way that you would write this out, the resistance of this specific resistor, is R equals 25 times 10 to the third plus or minus 10%. And remember, resistance is measured in ohms. So this chart will become very, very handy for you. Make sure that you're using it when you are given a resistor and you're trying to figure out how much resistance it has. Few little clarifications to finish off. Batteries maintain a nearly constant potential difference. So if I have a 1.5 volt battery and I plug that in, if it's a new battery, it is going to be pumping out or providing 1.5 volts of potential. That will not fluctuate very much. The current will change depending on what you hook up to it. Resistance is a property of a material or a device. So, for example, different kinds of light bulbs will have different resistances because of the materials they are made of. And finally, current and charge do not get used up, and this is a really important point. Whatever charge goes in one end of a circuit has to come out the other end. So when you think about it, if we have a circuit that has a battery and that's hooked to a light bulb, the electrons don't move through the wire, get to the light bulb and turn it on and go, pff, gone. We have a law of conservation of charge, and that tells us that charge is never created or destroyed. It is always just moved from one place to another. So what happens is the electrons will move through the device and continue back into the battery. Whatever leaves one terminal has to come back. So now go ahead and take a look again at these questions and have them ready to turn in the next time you come into class.